Good morning, everyone. My name is Raina Ghazi, and I am the Teacher Development Manager for Macmillan Education International Curriculum. Thank you so much for joining our webinar this morning. We have Andrew Jeffrey, who is our Singapore maths expert and author, who will be delivering an engaging session focusing on hands-on maths activities at home. I will be providing a handout through the webinar in advance. So where you have the questions box, just above that, there is a little column or row that will say handouts. So please refer to that in a few moments once Andrew gets started, and hopefully you can use those handouts during the session as well. If you have any questions, feel free to write them in the questions box, and we look forward to having you participate. Thank you.
Thank you, Raina, and hello everybody. Welcome to those of you from all different parts of the world. Welcome here from a very sunny Brighton in England. Now, I've been a teacher for many years, and I train teachers, particularly in maths, and I work with parents, and I'm assuming that some of you are teachers, some of you are parents, and many of you will be both. So during these unprecedented times, a lot of people have been doing a lot more maths at home than they have at school, and so I just want to share some things that work pretty well in either situation, actually. So I've got three basic goals which you might have seen for today. While I'm talking, you might want to grab that handout that Raina talked about. It will be important, and we will be referring to it. It's free, downloadable PDF. Just grab that link. Okay. If you can write on it, that would be helpful. So either you can do that on a tablet if you've got that technology, or a printed version as well, which will be just as good. Now, so as I said, I'm going to share some practical tips for you that don't require, professional teacher training or anything. I'm going to share the things that I'm going to focus on primary, but I'm going to go right from sort of 3-4 years old all the way up to quite challenging ones. And then we're going to leave a bit of time at the end because there's usually some people with questions, and I like to answer as many as I can. So let's start with a bit of magic. I just thought this would be fun. Okay, so there are 25 squares. Now, not all screens always look the same color, so I'm going to tell you the top row, whatever colors you see there, I'm calling those orange, red, green, blue, green. All right, so those are the 4 colors that I've used. Okay, and you'll notice that there's often more than one of each color in a row or a column. That's fine and deliberate. Now I want you to mentally select, or even with your finger, just select one of those 25 coloured squares. And then I want you to, from that square, travel up and down until you feel like stopping on any blue one. Now I've checked, and there is a blue one in every column, so you're fine. I noticed that in one column there's 2 blue ones, so you can just jump to either. That's allowed. Now from your blue one, we're going to go to an orange one, left and right. Okay, so left or right, go to a blue one. An orange one, sorry. And then from your orange one, go up and down till you come to a red one. And again, if there's more than one red one in your column, just pick either. And then go left and right and stop on any green one from your red one. Now, we've all started at different places in the grid, so we'll all end at different places in the grid. At least that's what you'd think. But of course, if this was magic, we might all end right there. So give me a yes in the question box if you ended up there, and I'm going to try and use the technology to check the question box. This is working. Here we go. Greetings. Oh, we've got 1 no and some yeses. Someone wants the instructions again. They're all on that screen there, Rajika. So very briefly, start anywhere, go up and down, stop on a blue. From the blue, left and right, stop on an orange. Up and down from the orange, stop on a red. Left and right, stop on a green. And what happened? Yeah, most people are getting to yeses, lots of yeses. Well done. And this is the thing, you'll always end up on there. And that has to generate in your mind the question, why does that happen? That's how's that predictability? And that kind of wondering and that predicting about pattern is at the heart of mathematical learning. So I think before we start, I'd like to use that. By the way, feel free to use that trick yourselves on your children. I'd like to start with what I think is quite an important quote, which is to say that maths is just about adding, subtracting, multiplying, dividing, is to say that Michelangelo is just about chisels. See, the whole point of Michelangelo wasn't really his chisels, was it? It was what he created by using them. And mathematics is what we create by using these tools. So we need to become very good at using the tools, but only so that we can create something. I think one of the reasons many children don't enjoy mathematics is because they never get to create anything with those tools. They're just boringly doing the same old thing every day without really seeing the beauty that they can get from mathematics. So with that in mind, let me talk to you about what I think is the best way for children, young children anyway, to start with learn math. Now, this is my home city, Brighton and Hove in the south of England, and there's quite a lot of traffic in the city, and so public transport, we've got a very good bus service, and most, if not all, children in the city will use buses in the first few years of their life to get around, and they love going on a bus because it's more open than a car, and it's quite exciting, and they get in, they physically engage with the bus, they understand what a bus is, they hear the word bus, and so when they see a picture of a bus, this is a very iconic bus, I'm sure you know which city this one's from. It's funny, everywhere in the world when they're making a movie and they want to show you London, this is what they'll show you, a red bus. That's like, seems to be the stereotype for our capital city. But even though children haven't seen a bus like that before, maybe they haven't seen a completely red one, they'll know. They'll just go, oh, that's a bus, because they learn to see the features and the structures that make it a bus, even though it's not quite the same shape and everything. And then once they've done that, even if it's a photo of a bus, because they've been on the bus, they'll even understand this, which doesn't really look exactly like a bus, does it? It's a cartoon representation, a kind of iconic representation of a bus, if you like. It's a symbol for a bus. And that's okay, they can do that quite quickly because they went on the bus in the first place. They had a physical engagement with it. But then, of course, these things all take place over a matter of weeks and months. They can learn this, but then it gets much more difficult because they're expected to, by the age of about 5 or 6, be able to read that. Now, that doesn't look anything like a bus to a child. So that's why reading takes so much longer, doesn't it? And that's why picture books are the first books children look at. So if we want to help our children with maths at home, let's not forget that actually numbers are really complicated things. Just put in the question box what you think that is. There's something that I've drawn. I'm just specifically talking to the sort of oval shape with a big long tail on the right hand side of that. Just write down what you think that is. I'm sure you'll recognize it. I'm going to go over to the questions and see what people are putting. Do we get slides? Yes, you do. It's a musical note. Yeah. Anyone else want to come up with a different answer? It's quite a differentiated question, this, because if you just regularly recognize it, you could say it's a musical note. If you knew music, you could say it's, let's see if anyone's got it, an E. I think it's a G, close, okay. So you could actually, notes have names, there we go, okay, notes have names. Someone's talking about major and minor. So actually, it's a piece of music, so let's listen to it. Curious, probably all you heard there was the hum of my laptop. And not actually any music at all, because although we say it's music, it isn't. It's a code. If someone was walking along outside your apartment with this piece of paper, your house with this piece of paper with these notes on, you wouldn't lean out and tell them to be quiet, because that's not actually music, is it? And it's the same with numbers. You know, if I say what's that, you'd be tempted to say it's 4, but 4 what? If you're, a young child learning about it, that's not 4 anything, is it? It doesn't even look like 4 things. Somebody once said to me, it looks like a picnic table in the wind. But if I said to a child, can you draw something that's twice the size, they might go with that. Whereas you might have been thinking about that. And if I say, 4 is half of 8, if I say, can you show me half of 8, they might draw that, or even 0. And so on. Look, 3 is the highest number there, is it or not? So therefore, this is a way of explaining very carefully that we need to be careful that our math doesn't just involve these numerals. It involves much more visual representations of number for children. Okay, right. So let's start with this. I don't know what these are called in your country, but I rather like them. Okay, little hard, sugary sweets. But they're not the Skittles we want to talk about today, sadly. These are the Skittles. Now, this game is played around the world, and you might have a set at school. You probably wouldn't necessarily have a set at home. the kind of thing that playgroups might have. But these are brilliant for maths. So I can't believe there isn't anyone who doesn't know, but just in case, you roll one of the two balls, and the aim is to knock down as many of the Skittles as you can. Then you roll the second ball and try and knock down as many of the remaining Skittles as you can. Okay, and in the standard version of the game, you score points equal to the number of Skittles you knock down. Now, how can we play this at home? Well, I've been thinking about this a lot, and plastic cups substitute for the Skittles very well. They're pretty straightforward, and they don't tend to break. That's important, isn't it? Don't use glasses. And well, anything really that you can find that will stand up and will fall over is okay. You might even be able to stand shoes up on the heel. Not all shoes are suitable for that. But instead of the balls, use a pair of socks balled up. They make a really safe alternative to throwing a ball in your house. Okay, I've learned this from experience. Okay, I've never had a child break a window with a pair of socks, but I can't honestly say the same thing about a ball. So just thinking about maths at home, those are some alternative arrangements you can make. But anyway, what are the advantages of this? Well, first of all, obviously, what's my score? I have to count. And counting physical objects is the first step to learning to count abstractly. All right, counting objects, learning that correspondence of one word to one item, 1, 2, 3. Okay, but then of course, if you have two balls, as in the traditional version of the game, you get two different scores. I knocked down 3 the first time and 2 the second time. What's my score? It's 3 add 2. So I've got to concatenate those to put them together, aggregate them, and that's good. That's good practice. But what about this? If my first pair of socks or my first ball knocks down loads of Skittles, and there's just 2 left standing up, am I going to count the number I knocked down, or is it actually quicker to say there are 10 Skittles to start? You can see in that picture, hopefully there are 10. There are 2 standing up, so how many did I score? And so that really important idea of number bonds to 10 starts to be built in. What else can we do? We can do it with times tables. I could say you get 7 points for every Skittle you knock down. How about that? If I knock down 5 Skittles, that's 5 7s, 35 points for me. That's a brilliant one. Or you could, if you wanted, have a mystery and paint different numbers on the bottom of each Skittle. Okay, not so good when they're all different colours, but if they're all the same colours, then who knows? You can do a similar thing with table tennis balls throwing table tennis balls into cups where there's a piece of paper inside each cup with a number on. So anything really that gets them doing a scoring system. You could do subtraction as well. You could say, right, you've got 50 points, and every time you knock down a Skittle, you take 1 point away, and the winner is the first person to get to 0. So you see there's a whole range of ways you can do really great mathematics, but actually it doesn't feel like maths because you're just having fun with your children. It's got to be a winner, right? Okay. There is so much opportunity here. Let's start with something else. I don't know about you, but in these days of COVID, we've been doing less shopping, but we still need stuff, right? So we tend to get it delivered, which means that if you're anything like us, you've probably got quite a bit of cardboard in your house right now. And I'm sure you'll be recycling it soon. But in the meantime, why not cut it into little squares and get children to work on this very simple task? How many shapes can they make if they're allowed 3? Now, there's one shape, there's another shape. Is that a different shape? And is that a different shape? And you could say, well, maybe it is, but actually if I rotate that one onto there, and I can rotate that one onto there, so maybe you can only make 2, I don't know, there's a third one. Now you have to put some rules in place, like an edge cannot partially overlap, it has to completely overlap. That's the rule I've used here. Okay? Because if it can partially, there's an infinite number of ways of doing it, and that's no good. So I said that completely overlap, but of course they can do that, and then you can investigate. So there's with 3 shapes, there's 2 ways. What about with 4 shapes, I wonder? Well, I suppose the old straight line again, we could do that. Straight line with one bent round, a square. Are there any others? And actually there are, and investigating how many there are that aren't just a simple twist of another one is interesting. And then of course you go to 5, right? Is that another one? And so on and so on. No, because that one fits on that one, and so on. Okay, so there are lots and lots of possible solutions, possible variations, and all you're doing is cutting bits of cardboard into squares. So I'll give you that as a really fun anything to do with shape. It's not all about number maths. A lot of it's about shape and pattern and geometry and seeing the world in the 3 dimensions as well. Okay, now hopefully you've all had enough time to grab your handout. Okay, so you've got your PDF, which looks, if you've got it, like, hold on a second. There we go. It looks like this. There we are, a Maths at Home webinar handbook. Okay, and here's the first couple of pages. And so I'm going to introduce you to a couple of tasks here. First one is called Today's the Day. And it is, in fact, the 16th of the 6th, 2020. Now, we're going to use those 6 numbers for a little mathematical investigation. And excuse me. And the beauty of this is, of course, obviously, this date will never be exactly the same for another 100 years. So you're probably not going to be too worried come 1606/20, the next time it comes around, meaning you've got a brand new activity, a brand new game for every single day for the rest of your life without ever having to plan it. There we go. Now, the way this works is you'll notice that I've put the 6 digits of the date spaced out. And if I switch back to my date, okay, let's show you how that looks. Okay, what I've done is I've spaced them out so that I can put pluses, minuses, divides, multiplies, equals, and brackets. Those are what I'm allowed in between to make a new calculation. And here's how it looks. So here are just 3 examples. First of all, could you just ignore the yellow and just look at the white? What you'll see is the white is identical in every row. It's just those 6 digits in that order. But now if you look at the yellow, you'll see what I've added in are some pluses and minuses and times and divides. I don't think I've used any divides on this one, but you can. And some brackets for changing the order of things. Now, if you give children a free run at this, they'll be able to create things. So, for example, in the first line, really simply, I've just put 2 plus signs in. So that top row now reads 16 plus 062, 62 plus 0. And so that makes 78. And the idea is to make different numbers, see what different numbers you can make. So I've made 78. Look at the next row, I made a much bigger number. Here's how I did it. 160. So I made a 3-digit number here again. Then I decided to subtract 6, which gives me 154, 154 times 2, 308. Again, plus 0, 308. And the last one, it's a bit different because I put my bracket at the end. So the bracket we work out first, that's 6 times 20, 120. And then we add that on to 1 times 6 times 0, which is equal to 0. So 0 plus 120 is 120. All right. So I want you to have a go at this. I want you to put it in the question box, what you've made. So just basically write 160620 and then put anything you like in between them. And let's see what you can make. Let's see what different calculations you can make. I'll hand it back to you guys. Let's see what we've got here. Odd maths concept, it is indeed. Let's see what you can have a play with. Who's going to be brave and put one up? While you're doing this, while you're thinking, I'll tell you of an amazing variation I came up with. What's nice about this is, I don't know if you've come across the game Countdown, where contestants are given a series of numbers and then a target number. So I might give you the 160620 and then say, can you make 308? Which is of course much more difficult, and children tend to fail at that. Okay, so I didn't want something where they failed all the time. So this which I'll be honest, kind of came to me on the spot. Here we go. We've got a 160 plus 620 is 780. Very good. Now 16 times we need a 0 in there because you have to use all the digits in that order. Oh, we've got loads more. Here we go. Yeah, guys, you got the idea. We've made 0. Okay, if you want a massive challenge, my challenge to children in the end, when they played this a few times, was can you get a point for your table or your team for between 80 and 120. Anything between 80 and 120, you get a point. And you get 5 points or 10 points or 1,000,000 points or whatever you want if you get exactly 100. Now you can get exactly 100 today. So I won't spoil it by telling you how, but it can be done. Okay. Right. That is the date warm-up. And now the second one, I'm not going to do the dice now, actually. I'm going to go onto the pyramids. So on the next page, we have our pyramids. And let me show you how this works. So could you write the numbers 2, 3, 1, 5, please, in the bottom row of your first pyramid? That would be brilliant. Okay. Bottom row of your first. Loads of you, I'm just checking the question box. Loads of you are putting your answers in, which is great. Okay. Now, the way this, I'll just move my mouse back here. The way this works is you now have to challenge children to fill in the rest of the pyramid using a very simple rule, and that rule is addition. So the brick on top of 2 and 3 is the total of 2 and 3. The brick on top of 3 and 1 is the total of 3 and 1. The brick on top of 1 and 5 is 6, and so on. So if you would like to complete that pyramid, and you can put your what you get in the top brick, I want to know what the top brick is, put that in the question box, please. We've got 5, 4, 6 is the next row. Yeah, what's the next row? Let's see who's got there. Yep, there we go. I'm seeing some folks sort that out. Yeah, well done, Phoebe. Well done, Chitan. Well done, Smita. Well done, Renee. Yeah. Okay, so there you go. 9, 10, and 19. Now that's quite interesting. Okay, it's a fun way of like practicing, like warming up the muscles. But there's quite a nice variation, which you can just give some of the bottom numbers and some higher up numbers. So you might want to have a go at that one. It's the same rules, but now we don't have the information that we had before. We don't have the whole bottom row. And yet, interestingly, it is still entirely possible with just those 4 numbers to fill it in. So if you can work out what number goes at the top of this one. It gives me a chance to sip my coffee and see who's paying attention. Okay, let's see what we've got. Okay. Fantastic. Okay. How are we doing? All good? Yeah. So I don't know where you started. For me, I thought that was a good place to start. That has to be 4 plus something is 9, so that has to be a 5, has to be the something. Or maybe you started here, so 1 plus something is 3. Okay. We can, for children who you think this might be too easy for, it's very easy to make it harder. Just give them, start with fractions on the bottom. They'll need a little bit more information, but that's enough there. Okay. So there really is a huge amount of possibility with this task. Okay. And you've got a whole range of, you've got a whole page full of ones there. You can always print it out again. You've got my full permission to photocopy it. That's fine. Last one of these, and it is this. If I've got 1, 2, 3, and 4, and I can put them in any order along the bottom, what different totals can I get? And do you spot a pattern here? And can you explain the pattern? Okay, so I'm just going to leave that as a puzzle for you to work with your children, because I want to show you our next exciting thing, which is this. Now, it's a resource that I think should be certainly in every classroom, and not necessarily in every home, but you don't need to be a school to be able to download this book. And the good news is it's totally free. It was published by the UK government 10 years ago. It's got an awful title. I really object to the idea that only able pupils are allowed to look at this book. Okay, nonsense. Anyone can have a crack at this. Okay, it's really suitable. And in case your nomenclature is different in your country, key stages 1 and 2 basically means children who are between the ages of 5 and 11. So it's more or less the primary range. Okay. And it's got a series of, it's free. You can, if you download, if you do a web search for that exact title, Mathematical Challenges for Able Pupils, you will find in Key Stage 1, 2, you will find that book freely downloadable as a PDF. Okay, literally free to use, no copyright and all that. And it's got some like maths investigating stuff, which is really great. So here's one that I like. Jay bought a gobstopper which costs 6p. You pay for it exactly which coins to choose. Now, clearly you're going to need to edit this for your own country. The best way I've found to edit these, by the way, is in PowerPoint. If you do a screenshot in PowerPoint and then you use a rectangle, a white rectangle, to cover over where it says, for example, 6p, and then you could change it to dirhams or cents or dollars or ringgit or whatever currency you're working in. All right. So you pay for exactly which coins to use. Now, the only bit I don't like is it tells you there are 5 different ways to do it. I think it's better mathematics to say how many ways can you find to do it, not tell them there's 5. Because if you tell them there's 5, they'll stop thinking, they'll think they've got permission to stop working. But the best thing about this is the what if. What if it costs 7p? And I think some of the best maths questions ever asked are, what if? I think all the good questions start with, not all, many good questions start with that what if. Here's another one. I really like this one because this one isn't just theoretical. You could recreate this. You could, again, get the old socks out and get some bowls or plates, okay? And you can recreate this one. And again, the best thing about this one is question 4 there, look. What other scores can Dan get or as a winner? Right. No, not that one, that's not the right one. Now, next thing I want to show you is some dice activities, and these are really great. Okay, so again, in your handout, if we have a look at your handout, you'll see the page we need, excuse me, just grab it, is this page here where it says dice. Okay, so we're going to look at 3 dice games with you very briefly. First one is called Greedy, second one is called 3 to 10, next one's called Big Score. So if you are all ready, here is the dice. Okay, right, Greedy, here are the rules of Greedy. I'm going to roll a dice and as many times as I want. Okay, now for the purpose of this webinar, I've got these rubber dice because they don't make a great big clatter when I roll them on my table. Okay. So there we go, 6, 4, 4, 5, 4, 1, and so on. Now, I basically keep rolling as long as I want. This is interesting, isn't it? My turn can be as long as I want it to be, but I'm trying to get as many points as I can. And the way to get points is simply to add up all the rolls you get. So my first roll is 6. I could stop there, and then my score for that turn is 6. Or I could roll again, and I've got a 4. So my score is now 10 for that turn. I'm gonna roll again. Oh, it's a 1. It actually was. I was going to lie, but it actually is a 1. And so I lose all my points for that turn. Not since the beginning of time, but just for that turn. And now it's your turn. So let's say you get a 5, you roll again, you get a 3, you've got 8 points. You're a bit more cautious than me, so you say, right, I'm going to bank those 8 points. Now it's my turn again. I start from 0 because I was greedy. You start next time from 8, you see. So I'm going to go, okay, so I'm on 0, 3, 3, 5, what's that, 3, 6, 11. I'm going to stop. So now I'm on 11. I can never lose those 11. Now it's your turn. You start from 8. Oh, you got a 1 straight away. Okay, so now it's my turn. I start from 8. Okay, there you go. So it's just constant mathematical addition, constant decision making. A lot of luck, so it won't always be the cleverest person that wins, which is good. So there are strategies involved in this. How many rolls should you take? Are you a risk taker? Are you a bit risk averse? How many points should you say I'll just roll for X rolls, or I'll just do it till I get this many points? And there are actually some quite complicated mathematical things that are going on, but you could play it for 5 minutes. My favorite version is like a sand timer because it adds a bit of a 5-minute timer, or a Pomodoro timer. I've got one of those. Just time on your phone. Just say, right, after 5 minutes, whoever has the most points is the winner. Whoever's winning at that point is the winner. Okay, whoever has the most point banked. Or you can say first to 50. It's entirely up to you. Okay, but there are lots of different ways of playing greedy. Okay, our second dice activity is called 3 dice to 10. So here, instead of 1 dice, I've now got 3, and I'm going to roll them, and I've got a 3, a 3, and a 6. And can I combine those numbers in any way to make 10? Now I have to use all of them, okay? I can't have a 5, a 5, and a 2, and then go, I'll just add the 5 and 5 together. That's not allowed. So a 3, a 3, and a 6. I can get quite close, can't I? I can say 3 plus 3 is 6, plus the other 6 is 12. That's quite close, but I don't think I can get any closer than that. No, unless you can think of anything. No. All right, so 12 is my best attempt. Let's see if we can go again. Now this time I've got a 5, a 6, and a 2. Okay, what can I do here? I can get quite close. If I do 6 take away 2 is 4, plus 5 is 9. I can get really, really close. Okay, let's see, one more go. Oh, 1, 1, and 2. That looks a bit rubbish. No, I'm not going to get anywhere near there with that, and so on. So see if you can roll your dice. I've got a 2, a 4, and a 5. Now I can see a way of doing it with a 2, a 4, and a 5. I wonder if you can. So 4 minus 2 gives me 2, times the 5 is 10. I could have gone 4 divided by 2 equals 2, times the 5 is 10 as well. That would have been just as good. Okay, so there are loads of different possibilities, and you can say, right, you get 5 points if you get exactly 10, you get 3 points if you get within 1, you get a point if you get within 2. You can ask children to design their own scoring systems if you like, okay, which is a really nice thing to do. Our final dice game, I'm going through these quite quickly, I want to leave plenty of time at the end as well to talk to you. Our final dice game is called Big Score. Now, Big Score is one of the favorite things that whenever I do teacher training sessions, I often include this, and honestly, they really like it. So can you see beneath the Big Score, you should see some grids like this. You should see 4 boxes and a less than sign, and in the middle of those 4 boxes. So effectively, we've got 2 2-digit numbers. Okay. Right, now I'm going to roll a number, and actually it's a 6. Okay, it is a 6. So here's what you do. Put a 6 now, please. We're just playing the top row of your handout. Put a 6 in one of the 4 boxes. You've got 4 choices, either one of the ones on the left or one of the ones on the right. Okay. And depending on where you put it, it's obviously worth either 6 1s or 6 10s. It's entirely up to you. Now you put a 6 in, here we go. Could you put a 4 in one of the other boxes? Okay. Put a 4 in. And don't be afraid to do this, actually physically write these in. Okay, and the third number is a 2. Okay. And a 5. Okay. 6, a 4, a 2, and a 5. All right. Now you've written something. You might have written, if you went left to right, you'd have written 64 is less than 25, which isn't actually true, but that's fine because I haven't asked you anything about whether it's true or not. So in the question box, I'm going to look. Would you type in what you got, please? Type in your inequality. So if don't worry if you put 64 is less than 25. I will know that you don't really think that's true. Don't panic. Okay. So let me watch and see what we've got. So I've got 26 is less than 45 from James. Can't argue with you. Well done. Yeah. Oh, well done. Oh, look, you're also honest. Oh, someone's made up their own numbers there. 98. It's interesting. It's more like, yeah, those numbers weren't actually on the dice, so I'm not allowing that, Rajika. Sorry. Okay. 26 less than 45. Okay, answer. Right. Well done. 56 is less than 24. Okay. 25 less than 60. All right. Now, here's the thing. Sometimes you will write something that's not true, and if you do that, that's okay. You score no points for that round. Okay, because we don't want to reward untruth. Okay. But if you write something that is true, such as Thangy's done there, 25 is less than 64, you get the number of points equal to what you wrote on the left. So in your example, 25 is less than 64, you get 25 points, okay? I think that's probably why somebody went for 98 is less than 99. Cute, but no, okay? You get no points because you didn't use the numbers that we showed you. All right, 2, 5, 6, and 4. Now, what's really nice is you've got to try and get as big a number as possible on the left, but also still make it a true inequality. So there's loads of ideas around place value and stuff. You'll notice I've given you a few rows because it's nice to play a few rounds and then add up your scores. The last round, where it's got 3-digit numbers, is so that anyone who's a bit behind going into the final round still has a kind of chance to win. I like that. Our next goal wins sort of idea. Otherwise, the heads can drop a bit, and that's not what you want. Something else that's nice about this is my favorite round is called the time turner round. So imagine you could go back in time. I'm just going to recreate what we actually got there. So I think we got a, what did we get first? Was it a 2 or was it a 6? Let's say it was a 6, a 2, a 4, and a 5. Let's say these are the numbers that we got, all right? In the order 6, 2, 4, 5. Now here's what I'm going to do. I'm going to go back in time to pretend that we haven't yet played this game. Okay. And you know what numbers are coming up now, but you still have to play at the same pace as me. So you can't instantly write anything down. You have to wait and put the numbers in as they come up. Okay. And you have to walk around to make sure it's on the right. Hello, everyone. Just boom, one back time. You would like to play a game called Big Score. It's very exciting. You put one of the numbers in each box every time I call it. So here's the first number. It's a 6. Who knew that was going to happen? What a surprise. Put a 6 in one of the boxes for me. And now let's see what we get now. Oh, a 2. Who knew? Okay, put a 2 in one of the boxes for me. The third number is a 4. Well, there's a thing. Okay, put a 4 in one of the remaining boxes. The last number is, let's see, oh, a 5. Oh, okay, now, you see, you might have thought it would be easier that time, but in my experience, it's not easier. So just knowing what's going to come doesn't necessarily make it easier. So I'm hoping, I wonder what score you got that time. Let's have a look. If was anyone honest enough to play along? Yeah, 54. Okay, there you go, 54. Now, a couple of things I've learned from playing this in the real world. Okay, children will try and cheat. That's just the nature of things. Okay, so you have to be quite sticky. Now, if you're just playing with one person, that's fine. But if you're playing with a group of children in a classroom, I know this is about at home, but those of you who are teachers, I know some are, you have to make a couple of things clear. Firstly, you have to say, now, if you'd like to score 0, and I always score 0 on the demonstration round, so they don't feel quite so bad about it. I call myself a 0 hero, and I make light of it to help them feel better. Okay. Then, if you want to score 0, then just cross something out, or change your mind, or move it. Okay, that's fine, and then you'll score 0, and we'll still be friends. That's the kind of light way I say it. The other thing I say is, at the beginning, I say, now, you've put a number in one of the 4 boxes. That it was a whatever it was. I don't know what the first number was. 6, maybe. Okay, so now there's 4 boxes, so you might have not have put it in the same places as the people near you. Why don't you have a look around? Just have a look at each other's and see if you've put it in the same place as the people near you, or maybe somewhere different. And what that does is it makes sure nobody's cheating by not putting the number in until they know what the other numbers are. But you don't have to say, make sure no one's cheating. It's just a really nice way of using language to make sure nobody cheats. Okay, so there's a kind of top tip from me, something I learned the hard way. So you should win, Christopher. Yeah, you should win. You should get 54 points on that round, but you'd be amazed not everyone actually does get 54 points. Okay, so that is the big score. Okay, the next thing I want to share with you is arithmetic races, and again, we'll find that if we switch to here. Arithmetic races. Now these are, you can make these, okay, you can actually make these. So you'll see we've got player A. Okay, I wonder if I can zoom in a bit for you. Here we go. Okay, there's 100 of these altogether in arithmetic races book, but they're easy enough to make. So you just make a table, and you can call it like me and you, whatever, and you put things in here. So my example would be, imagine a tennis match, okay, but it's a cooperative tennis match. You're having a rally, and you're jumping from left to right. So player A, let's say I'm player A, I'd say 6. And then follow the arrows. You just keep following the arrows. So you would have to say, 12, because you've doubled it. And then the arrow goes down to the left. You see it. So I would say 24, and you would say 32, because you've added 8, and then I would look and I say, oh, I have to halve now. So this particular one, I'd go 16, and then you'd halve 8, 4, 2, or plus 8, 10, times 2, 20. Okay, and we could time ourselves and see how quickly we could do this. And then you could put some, but you don't have to do double and halving. I've got addition and subtraction in this one, do you see? Addition and subtraction is really easy to do, and I've just gone for decimals so that you can see it doesn't have to be a very simple trivial problem. Okay, it can be quite a complicated problem that you can make up. So these are fun to make up. I've got 100 in this book, Arithmetic Races, and people, I didn't think anyone would ever get through all 100, but after about 2 or 3 months of people buying Arithmetic Races, they went, we finished them, we want some more. So one summer I just sat down for a few days on a sunbed and wrote wrote Arithmetic Races too. So there's 200 there. All right, it's a really great thing to do. I can thoroughly recommend that. Okay, now I want to share with you some card activities. Okay, so here's a pack of cards. If you don't have actual playing cards in your house, that's fine. Just again use that cardboard from all your online deliveries and just write the number 10 on it. You know, write the number 5 on it. It doesn't have to be. There's nothing particularly magical about a playing card. Although, having said that, for those of you who are teachers and familiar with CPA, this is a concrete thing. P, pictorial, you see the 5 pattern, and A for abstract, you see the abstract symbol in the corner. So actually, if you're in a culture where playing cards is fine and accepted, then go for it. All right, these are the best thing, but certainly using numbers on cards is absolutely fine too. And there are other card games that have numbers on. So here's a fun thing to do. I Spy products. Let me show you how this one works. This is a bonus one. Okay, very quickly, put some cards out. All right, and I might say 45 because I've spotted 2 cards next to each other with 45. And if you can find them, there you go. 9 times 5 is 45. Then you win them. Okay, 24. Oh, I can see 24. I can see 24 horizontally there. Okay, or there. Yeah, or actually, I could have gone for the 6 and 4 in the first column. 20. Can you find 2 numbers whose product is 20? Okay, so that's just a fun game. There's no winners or losers. It's just one of those nice activities. But there's 3 in your book that I want to draw your attention to. 3 very quickly. So let me show you the page you need on here. Here it is. Card games. Oops, wrong page. Card games. So flip 3. Similar to what we've just done, except you deal the cards out face down. You shuffle them up, obviously. Take out any cards that look like this. Okay, jacks, queens, kings. Take out those and just have the numbers from 1 to 10. I always say that aces are just 1. I know in some games they're worth more, but I just call them 1. It's just easier. Okay, and all you do is you turn over 3. Now here I've deliberately shown a 2, a 4, and an 8, and I can call out a calculation, an equation. So I can say 4 times 2 is 8. So I win those cards. I get an extra point if I can say 2 times 4 is 8, 8 divided by 2 is 4, and 8 divided by 4 is 2, because that helps connect the relationships between multiplication and division. Okay, so if I can say those things, then I take those cards away. And again, you just keep going until there's no cards left. I've only drawn a small grid, but actually, if you take out all the picture cards, there are 40. So you can do it like a 5 by 8 grid, okay, with the non-picture cards, the 1s to 10s. Next activity here, you can see it's called 25 up, 5 up. 25 up is a super game. It's really simple. You just need, I'll take them out for you, a 1, 2, 3, 4, 5, and 10. So you just need 6 cards. It doesn't matter what suits they are. It just matters what the numbers are. And you shuffle them. You give them a mix. Give them a mix up. And you turn them over 1 at a time. And you keep a running total. So 3, 5, 10, 14, 24, 25. And of course, what's brilliant is it'll always be 25 when you mix them up again and have another go. 4, 14, 15, 17, 22, just pausing there, 25. Okay, so children know that they've got it right. For older children, I like to increase the level of challenge by adding in a 6, 7, 8, and a 9. Okay, so now I've got the whole set from 1 to 10, and if I give those a mix up, and you'll find it'll make 55. That's more challenging. If you want another challenge, go down. So start from 55, subtract 55 minus 8, 47, 43. Oh, that's a tough one. At 34, and so on. Okay, 29. Okay, 29. So this is a really fun thing to do, and it's fantastic for practicing your mathematics, or getting your brain sharp. Okay. Last one here is called bonds snap. Now, the thing about bonds snap is we know what snap is. Okay, if I find two cards the same, he says, unable to find two cards the same. If I find two cards the same value, normally I can say snap. But in my version of the game, I can only say snap if I have two cards that add up to 10. Sorry, that was my phone ringing. I thought I turned it on. 6 and 4 makes 10. Okay, so exactly the same as snap, but it's for younger children to learn their pairs to 10, which is such an important thing. Right, last one. I hope you're ready for this. Can you all find the page on your handout that says, let's dig it out, 5 by 5. This is the one. Okay, and then we're going to open it up to you guys for some questions. Okay, so I have removed again all the jacks, the queens, and the kings. So I've got 40 cards, which are number cards. And what I'm going to do is give them a shuffle, and I'm going to call out 25. Okay, I'm going to call out 25 of them. But and you're going to write the numbers in each of these squares in any order you like. You don't have to start in the top row or whatever. Okay. And then you're going to get some scores. Each row has a way of scoring it. I'll tell you how. Each column has a way of scoring it. And so those circles are your 10 scores. And then you add up all 10 and put them in the big rectangle at the bottom. Now, let me tell you the rules for scoring, because it's very, very clever, the rules for scoring this game, 5 by 5. Love this game. Okay, here we go. So here, here's a partially completed grid. You're aiming for a massive score. Okay, that's the aim of the game. So let's say you've put some 3s in there, 4s and 10s in the top row. The top row scores 26 points. Just give you a moment to think about why you think the top row might score 26 points. And the answer is, I'm sure you got it. I'll put all these in. The answer is any number next to an identical number scores. And any number that isn't next to an identical number doesn't score. So in the top row, those 2 3s, they both score. That's 6 points. And those 2 10s score, that's 20 points. Okay, in the third row there, those 3 8s all score. So 24, 3 8s. The 7 doesn't score in the row, but it does score in the column. Look, if you look at that last column, I've got 2 7s there, so that's 14. If you notice, there's a third 7 there, but it doesn't score because it's not actually next to it. It has to be in a row or in a line to score. So it's a fairly simple scoring system once you see it. So hopefully everybody is ready. Here we go. I'm going to count off 25, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5. Here they go. 25 numbers. I'm going to give them a fair old mix. Okay. And we're just going to see what they are. Okay. So when I call out a number, just put it in the grid. There's an 8. Put it in the grid. A 1. Put it in the grid. A 6, put it in the grid anywhere you like. Another 6, oh, there you go. So that'll be your, if you, assuming you chose to put it next to the other 6, that's your first score. You're off the mark. Okay. A 4, oh, another 6. So if you play this right, you could have quite a few points already. A 2, notice I'm not giving you a huge amount of time. 5, a 7. A 9. If you're wondering how I know this, by the way, without looking, it's because I can see a reflection in my laptop screen. I'm not being psychic. Okay. A 1. I didn't suddenly realise this must look quite amazing from where you are. Another 5. Oh, there we go. If there's space next to your other 5, you'll be good. Another 1. A 10. A 2. Getting a little bit faster now. Another 5. Another 10. So that's really good if you can get 10s next to each other for obvious reasons. Another 1. Another 3. Another 8. Pretty sure we started with an 8. There's a 2 with a signature on it. Oh, another 10. Somebody could be doing very well. And a 5. Must be nearly at the end. A 3. There's a 1. Put a 1 somewhere. And that is, in fact, the last card. So there we go. There's my 25 numbers. The advantage of doing it this way, instead of making up numbers, is there's no argument. If someone says, no, there were 4 10s, you can actually look through and see whether they were. Okay, and then the idea is to find out who's got what points. So you don't need to put your score. Don't worry. Okay. You definitely don't need to put your score. All right. But in the actual game, that's what you would do. Are there any questions? I think we're more or less finished. I'm just going to jump on to if you have a question that hasn't been answered or won't be answered in the next few minutes, please feel free to get in touch with me using Andrew Jeffrey. Actually, this website's not quite right. Go to andrewjeffrey.co.uk. This QR code you can see here is a book, a totally free book aimed at parents helping children with maths at home. It's got all the best free web resources I could find, so you won't have to spend any cash on that. Okay, it's totally free, no strings. So help yourself to grab that book from that QR code. So there's my contact details. Here are, more importantly, the contact details for our hosts. And on that bottom one is the rather long and unpleasant link to the Maths for Parents book. But I'm assuming if I click it, oh, gone. Hello. Oh no, it's just loading it up. There we go. That's what it'll take you to. Okay, Maths for Parents. Discover the best resources. Just put your name in, put your email in. Okay, and we're good.
Thank you so much, Andrew. I'm just waiting to see if there's any questions. While we do that, just very quickly, a few people have asked a few questions about the certificates. They will be sent via email within 2 weeks, along with a PDF as well. The webinar recording will be available on our YouTube channel, hopefully within the next few days. So do look out for that. Also do follow us on social media. Sometimes there is a delay in the certificates. Please do check your junk and spam folder. Sometimes it's placed in that. And also we don't individually write names on the certificates because we just have a lot of webinars at the moment. So unfortunately at the moment we cannot provide this, but the certificates will be provided. Just waiting to see if there's any questions. Just a lot of thank yous. And yes, the certificates will be sent within 2 weeks. Yeah. So in that case, yeah, I think a lot of them are questions and just to say thank you. So in that case, we will finish the session here. Thank you so much to Andrew, as always so happy and lively, which I love. Take care, everyone. Hopefully we'll see you on another session soon. We do have upcoming webinars, so do look at our website for the next few webinars that are coming up this month as well. Take care and hopefully see you soon. Bye.